Hello dear students, welcome you all. In today's lecture, I am going to explain you how we can perform experiments of the physics in virtual labs, right? You know very well that many a times we face a problem that the instruments are not available in the college laboratory or they are not working properly. Or even in some cases, either teacher is not available in the college or laboratory staff is not available in the college. So even then, students, you can perform all these experiments by just utilizing the concept of virtual labs, right? In today's lecture, I will demonstrate you how we can perform an experiment in the virtual lab. And for it, I have taken the experiment, very simple experiment, that is to draw the to study the voltage ampere characteristics of a PN junction diode. You can see here, to study the voltage ampere, BI stands for voltage current characteristics, or we call it as a voltage ampere characteristics of a PN junction diode, right? Or voltage current characteristics of a PN junction diode. So you can see here, this is the PN junction diode, right? This is the circuit symbol of PN junction diode. We know very well, right? So this is the circuit symbol, right? This one, and this is the actual pic of the PN junction diode that is used in different electronic circuits, right? Different kind of PN junction diodes are available in the market. So they have different markings according to their use, right? But this is the circuit symbol, and this is the design of this one of the PN junction diode available in the market. So this is the diagram of this PN junction diode. You can see it has a potential barrier at the center. This side is P and this is N, right? So in P side, you know very well that P side has majority of holes, whereas N side has majority of electrons, right? And you have gone through the theoretical part of this PN junction diode in details, right? I'm just focusing on the experimental part, right? That is to draw the BI characteristics. So a BI characteristics means when we are going to connect this PN junction diode in the circuit, how this diode will behave in the circuit. I mean, what is its behavior on the application of potential difference, right? How the current will vary in across the PN junction diode, right? So we know very well that we have two choices for connecting this PN junction diode in the circuit. One is called forward biasing and other is called reverse biasing. Forward biasing means when we are connecting a positive terminal of battery with the P and negative terminal with the end side of the PN junction diode, then we call that configuration as a forward biasing. You can see here, I have taken the graph. You can see here, this is the forward biasing, right? And in forward biasing, you can see positive terminal of the battery is connected with this side, negative is connected with this side, right? Now, when we complete these circuits, then we vary the potential difference, we measure the current flowing in the circuit, and then we plot a graph between the applied voltage and resulting current, and we got this type of graph. Similarly, if I invert this battery, right, I reverse the polarity, then now it has either we reverse the battery or we reverse the PN junction. They had just reversed the PN junction diode. Now positive terminal of the battery is connected with the N side, negative terminal is connected with the P side. So we can say that this is the reverse bias and configuration, or this is the reverse biasing of a PN junction diode. We have learned all these things right in the 12th class also. And when we'll vary this voltage and measure the corresponding current, we will draw a table, right? You know very well. Then whatever value we got here, we'll plot a graph between the B and I for the reverse bias. Same situation was there, V versus I. Table will be drawn. So this is the graph that we theoretically obtain. So we want to get confirmation that if we perform this experiment, right, by taking a PN junction diode, then whether we will get this type of graph or not, right? So for it, I am going to use the concept of virtual lab, right? So to perform an experiment on the virtual lab, the first thing that you have to do, you must have an internet connection, and you have to, go to the Google search. You can see here, I am showing you. In the Google search, you will write down the PN junction diode practical on a virtual lab in physics, right? You got different answers. You click on the first one, right? There are different virtual labs run by the different, universities. Even for some foreign universities are running the virtual labs. You can use them, right? But I recommend you to use the virtual labs, created by our IITs, right? So they are, trustworthy, right? They have very authentic and, correct information there. So I recommend you to use only the virtual labs of the IIT. So this is the virtual lab, Ministry of Education, Government of India initiative, and it is, the interface that is designed and created by the IIT, right? One of the IIT of the India. Right. Now you can see here, you got directly to the experiment. So now I'm going to tell you how to perform the experiment. So this is the aim. Aim is to explain the structure of a PN junction diode, explain the function of a PN junction diode, explain forward wise and reverse wise characteristics of a silicon diode, explain forward and reverse wise characteristics of a germanium diode. Now you know very well that PN junction diode can be constructed from silicon or from germanium. Both of them are semiconductors, right? Now this is the theory. You have already gone through it, and I told you, right? The theory is given here. So you can go to this theory if you have not gone through this theory in your theory class, right? You can see here, this is the reverse vising, and this is forward vising, right? And this is the graph that I told you for the forward vising. This is, I think, for reverse vising, right? This is the diode equation, right? All these things are given here, right, in the theory, right? Now I'm going to the next part, pre-test. Pre-test means when you are performing experiment, right? You can see here the logo of our Indian Institute of Technology. I think it is IIT Kharagpur, right? So this is the module of IIT Kharagpur that I am using here. So you can see here pre-test. Pre-test means before proceeding to the experiment, you have to conduct a mock test, you can say. In that test, you can check your knowledge. Here it is, can a diode act as a switch? Then you can obviously it can act as a switch. You can attempt all these questions. Then after you can proceed further. If you don't want to attempt, even then you can go further, right? This is the procedure given here. This is the circuit diagram, right? Battery source. You can see the, first of all, you can understand the diagram, right? This is the source of potential, that is obviously a battery, positive terminal. This is negative terminal, right? And this is the resistance used in the circuit. It is used for controlling the flow of current in the circuit. Otherwise, the excessive current can damage the PN junction diode. This is the ammeter used to measure the flow of electric current in the circuit. This is the voltmeter used for measuring the potential difference appearing across the PN junction diode, right? This is for forward wise, right? The connection will be of this type, and this is for a reverse wise. The connections will be of this type, right? Again, you can see in the reverse wise, the diode is changed. The direction of the diode is this way, and now it is this way, right? Then this is forward wise for germanium. Same thing. It doesn't matter, circuit will remain same whether it is germanium or it is silicon, right? Same. So this is the procedure, right? Now I'm going to the part of simulation, right? So in simulation, right, what you are going to do, this is the, again, same thing that is given here, circuit, right? But before going to it, you will go to, right, draw circuit, right? This was for understanding the circuit that we already understood by going to the procedure, right? But when you want to perform the experiment, right, you can perform the experiment even here, right, directly. But I recommend you to draw the circuit, right, that is given here, right? So if you draw the circuit here, then even the same thing that you can do. But in this, this was the I'm telling you, these are the two links. In one link, they are giving you the option to draw the circuit, right, and then perform the experiment. What in one link, they are already giving you the drawn circuit, and you have to put only the values. You can see here, right? So this one, right? Circuit is already made, but you have to only put the values. So I'm going to the this one first, right? So you can see here the circuit was starting from here. We are going to positive terminal of battery to the resistance, then from the resistance to emitter, then next terminal of emitter to the PN junction diode, and then from PN junction diode to battery again, right? And then from this to virtual ground. You can see here the circuit, virtual ground is connected here. Now voltmeter is connected in parallel to this PN junction diode. You can see here, right? So you can connect here. So you can go to this one and this one. Now the circuit is complete. Now to check whether this circuit is correct or not, they are giving you an option, check connection. So right connection, right? The connection is right. Set resistance and input DC voltage. The interface is asking you the commands. Set the value of the resistance. So first of all, we have to set the diode. So here, choose diode. As I told you in the beginning that different diodes are available in the market according to their marking, right? You can see here the logo, Indian Institute of Technology, Kharagpur, right? So I selected the first one, right? Then this is the DC voltage that I am going to apply here. First of all, I am selecting the resistance. So if you want to select the resistance, suppose I am choosing the resistance of 1 kilo ohm. So in that case, you put the cursor here and then use your keyboard, or even you can use directly, but by using the keyboard, you can increase it gradually, right? I am 538. Now I am taking it exactly 1K. Now it is exactly 1 kilo ohm, right? Now what is the next thing? Now I am going to put the cursor on the DC voltage. What I told you in the beginning, we are going to increase the voltage applied here gradually, and we are going to note down the current flowing in the circuit, and the voltage that will appear at this PN junction diode, that will be noted by this voltage voltmeter, right? This voltage will be slightly different from this one. Why? Because some of the voltage will be utilized by this resistance. Some voltage drop will occur at this resistance. So we are interested in this voltage that is appearing across the PN junction diode. So now I am applying here. So I am increasing gradually. You can see now the voltage reading here is 0.3 volt. And what is the current? 0. So I want to put this value in the table. So add to table. You got here serial number 1 applied, a forward voltage 0, right? And forward current is 0, right? The voltage at this, here it is 0.3, but this is 0. 0 means the voltage at this PN junction diode is 0, right? Then again, I am increasing gradually, 0.3 now. Again, it is 0, no change, right? You can see here 0. So if you make it add to table, it won't be added to the table because current and both the values are 0, no change, right? Then again 0.4, no change, 0.5, no change, 0.6, no change, 0.7. Now 0.7, let me check 0.6. Yes, 0.6 we have a change. So add to table. No, I think 0.600, no change. 0.7 we got a change in both the meters. So add to table. You can see here it is added to the table. Then again increasing, again add to table. So go on increasing step by step and go on adding the corresponding value, and automatically the values will be added to the table, right? Now again I am adding, right? Add to the table again, right? Add to the table, add to the table, add to the table, add to the table. Now I am increasing the scale, right? Add to the table. You can see the meters, reading in the meters are also changing, right? As they are changed in the values. You can see these meters. right? Right. Now I got 15 readings, right? Actually, when you will perform the experiment physically in the lab, you will do the same thing. What you will do? You will increase the voltage gradually by, rotating the knob, right, of the supply, and you will keep down noting the voltage and current in the circuit, and you will maintain the table. So now this table is already maintained. What is the next step? The step is to plot the graph. So plot, put on plot, you will got the graph. The same graph that I talk about in the beginning, right? Here you can see the graph. I talk about the graph, right? This one the graph. So the same thing that I got here, right? You can see here, right? Starting from 0, we got this, and then suddenly rise in the voltage. So this is the, working of this forward wise configuration of PN junction diode. You can even download, you have the option of print, right? You can take the print, then you can save it, right? You get the printing option. Then if you got the printing option, you can go for the saving option also, right? So I'm not going for it. If you don't want to go for print, even you can take the screenshot, right? Or you can take the photograph by using your mobile phone, right? So this is the forward wise configuration, right? Now I'm going for the reverse wise, right? So for that, what I have to do, go back side. Now this was the already drawn circuit. So you can do the same thing here also, but here the circuit is already drawn. You have to just put the value of the diode, resistance, and DC voltage, right? Now I'm going for this one, reverse wise, right? But first of all, remove these two. Now I'm going for a reverse Y silicon diode. So you can see again the built-in circuit with all this interface, but I'm not going for it. I'm going for draw circuit, right? So again, same thing, right? The circuit will be this one, this one, this one. You can see now the direction of the diode is reversed. This one, this one, this one, and this one. So what is the next step? To check the connection. So connection are right, right? Then I am selecting the diode, sorry. I selected it, right? Now, what is the next step? Again the same thing. What we are going to do? We are increasing the voltage gradually, but first of all, we have took the value of the resistance. So again, I am taking 1K. Right? I make it 1K. Then I am now increasing the voltage gradually. Right? You can see here voltage increased gradually. Add to the table. First reading, then voltage increased gradually. Add to the table. Right? Voltage increased. Sorry. Add to the table. Voltage increased gradually. Add to the table. You can see the increase in voltage, but the current is increasing in a very slow manner, and we are using microammeter for the measurement. We know very well when a diode is reverse biased, we got a very small current. We have gone through the theoretical part of it, and that current is of the order of microamperes, but in forward bias the current was of the order of milliampere, right? So I am now taking it here, add to table. Here I am using directly increasing the voltage in a large gaps. Right. Now I am increasing it up to 13, so 29 volt, right? So I got this table, 13 values, right? Now plot. So what you plot you got? This is the plot, right? Again the same thing, right? So you go to the picture, this one, right? very slow variation in the current with the increase in reverse voltage, and a particular value, right, the current will increase very rapidly. That is the breakdown voltage of the this PN junction diode. So you can see here, right, in our PN junction diode, right, this is the graph increasing very slowly, right, but as we reached at this point, then the current becomes very large. It start increasing rapidly from 1 to 23, and then if we go to 30, because the reverse breakdown voltage of this diode is given here 30 volt. So if we actually I'm not proceeding to the 30 because this limit is up to this point, but if I will go to the 30, then this current will become very, very large. So another way is to decrease the value of the resistance, right? So in that case, add to table, right? But I'm not getting, yes, now the voltage is 30, or let's decrease it 30.4, then we got 39, right? Plot, but the plot is disturbed. But I think this plot that we got, we have to actually what I did, I changed the value of the resistance in between, right? So you have to keep the value of the resistance fixed. So you can repeat this experiment by taking the value of resistance like 395, even 100 ohm, right? In that case you will get different graphs. So here I'm getting multiple graphs because of I'm changing the value of the resistance. So you have to keep the value of the resistance fixed. But the thing that I want to tell you, that the graph you will get this type of graph that I told you in the beginning. That graph was exactly of this type, right? Reverse wise characteristics of PN junction diode. So this is the way of performing this experiment, right? So so this was the way of performing this experiment. Now I'm going back to this one. So we have performed the experiment by using silicon diode. You can perform it with the germanium diode also, right? You can find all the values and all the graphs with the germanium diode also, right? Like this was the aim, theory, pre-test, then procedure, right? Then simulation. Yes, this is the case of forward wise germanium diode, reverse wise germanium diode. The circuits will remain the same. Only the diode type of diode is changed. So you will get slightly difference in the graphs, very minute difference, but you can do it also, right? Then you can do it for the reverse wise also, right? Then after performing this experiment, very important thing is post test, right? You have to also attempt the post test, right? Just as you did in the case of pre-test, I told you in the beginning you have to perform the pre-test. You check your knowledge, right? So let me do it completely. I skipped at that point. Can a diode act as a switch? Yes, right? The voltage ampere characteristics curve is almost a straight line above the knee point, right? So if you go to you can see above the knee point, right? You can say it is yes, then it is yes. Reverse current in diode is a linear function of a reverse diode. No, it is wrong. You can see here reverse current is not a linear function, right? It is not. If it was a linear function, the graph will be of this type. This is the linearity graph, right? But the graph is this way, right? So the answer is this one, no, right? In a silicon diode, reverse current is usually very small, right? Which of the mostly used semiconductor? We know silicon. A diode conduct when it is forward wise, and the anode is connected to the positive supply, right? Anode means p-type semiconductor, right? So then after you have to do the submit quiz, you can get the answers, all the answers correct, right? Score 6 out of 6. So in the same way, you can test the knowledge by checking the post test. Post test will be performed by you after completing the experiment, both with silicon diode and with the germanium diode, right? And both the cases, forward wise and reverse wise, right? So you can go for this post test to check your knowledge gained. So this is about it. You can go to the references from where you can learn all these things. Your references are already given here, right? So I think this is the best way of doing the experiment when you are facing some kind of difficulty in performing the experiments in your lab, right? It can be you don't have suitable instrument for that, you don't have lab for that, you don't have a teacher, you don't have a laboratory staff for that. So virtual labs is a very wonderful concept that you can utilize, right? So in the coming lecture, I will perform some more experiments, right, which are commonly used or discussed in the undergraduation level syllabus of the experimental work, right? I will also come to the post graduation level experimental work in the virtual labs later. So thank you very much.